Welcome to the DIY Honda Garage channel. DTC P0657 references a malfunction in the Powertrain Control Module, PCM, power supply circuit, specifically related to its power supply needs. The PCM is integral to engine management and vehicle emissions control, as it processes data from various sensors to optimize performance. Typically located in the engine compartment, the PCM communicates with other control modules through numerous connectors and wiring. A faulty power supply can lead to a variety of performance issues in the vehicle, including poor acceleration or engine stalling. Diagnose this issue promptly, as delays can lead to amplified damage and more costly repairs. Ensure to use proper diagnostic tools, such as the Honda Diagnostic System, HDS, for accurate troubleshooting. DTC P0657 indicates a malfunction in the PCM power supply circuit, which is essential for the operation of the Powertrain Control Module. The PCM is responsible for managing various engine functions, ensuring optimal performance and meeting emission standards. When this circuit malfunctions, the PCM can fail to receive the necessary power, causing potential issues with engine performance. The PCM is generally located within the engine compartment, making it relatively accessible for electrical checks. Therefore, establishing the integrity of its power supply is crucial for proper vehicle functionality. The diagnostic tools like the HDS should be employed to confirm this error. Several factors may cause DTC P0657. A faulty relay circuit board could fail to effectively manage power distribution to the PCM, resulting in a circuit malfunction. Sometimes, a blown A7 fuse causes an interruption in the power supply, preventing the PCM from functioning correctly. Additionally, shorted or open wires in the power supply circuit can significantly affect the electrical flow. Identifying these faults promptly is crucial for resolution. Each potential cause should be examined methodically to ensure the reliability of the power supply to the PCM. Proper wiring checks and component tests will help pinpoint the exact cause of the malfunction. When DTC P0657 is present, symptoms can manifest in several ways. Drivers may experience engine stalling, which can be alarming, especially when driving at high speeds or at intersections. Additionally, there may be noticeable poor acceleration, making it difficult for the vehicle to gain speed. Increased emissions may occur as the PCM struggles to manage fuel delivery and ignition timing effectively. Understanding these symptoms helps in diagnosing the underlying issues efficiently. If any of these symptoms appear, it is crucial to investigate the PCM power supply circuit immediately. Ignoring these signs can lead to more severe engine problems in the future. The first step in troubleshooting DTC P0657 involves problem verification. Start by turning the vehicle to the on mode without starting the engine. This action powers the onboard systems, allowing the diagnostic tool to retrieve current codes accurately. Use the Honda Diagnostic System, HDS, to clear the DTCs. After clearing, start the engine to monitor if the DTC reappears. If DTC P0657 is confirmed again, proceed to the next step. However, if it does not appear, the issue may be intermittent, hinting at potential loose connections or other wiring issues. Always document the conditions under which the DTC was recorded to identify any patterns during later tests. Step 2 involves checking the relay circuit board. Begin by turning the vehicle to the off/lock mode, ensuring safety as you remove the relay circuit board for inspection. The relay board is crucial as it manages the power supply to the PCM. Testing the relay board will help verify if it's functioning correctly. If the relay circuit board passes the test, proceed to the next step. However, if it fails, Replacement is necessary to restore the proper operation of the power supply circuit. Always ensure that any replacements are genuine parts to avoid future malfunctions. During the third troubleshooting step, you will check the A7 fuse. The fuse is an essential component that protects circuits from electrical overloads. It's crucial to examine its condition rigorously. If the A7 fuse is intact and operational, you can move on to the next step. Conversely, if the fuse is blown, this indicates a failure in the circuit that needs attention. Replacing the blown A7 fuse is essential to restore power to the circuit. Always consult the vehicle's service manual for the correct specifications if a replacement is necessary. Step 4 involves determining the possible failure area by checking continuity of the circuit. Remove the blown A7 fuse and verify continuity between test points 1 and 2 during this process. It's advisable to conduct these tests while the vehicle is in lock mode with the relay circuit board removed. Test point 1 is at the relay circuit board connector C18P, female terminal number 18, while test point 2 is the body ground. If continuity is confirmed, this suggests a short in the +B IGP wire, requiring repair and replacement of the A7 fuse. If there is no continuity, further investigation will proceed to the next step to isolate the issue. The fifth step involves checking the internal circuit of the parts related to the power supply. Start by jumping the SCS line using the HDS and allow over 1 minute to observe the conditions. Disconnect individual components such as the PGM FI main relay 2 or the PCM connector A, 50P, and check the continuity at the specified test points. If the continuity disappears when you disconnect a component, it indicates that the part may be faulty and should be replaced. If the suspect part is the PCM, reference the authorized service information to ensure you are addressing all related DTCs or symptoms effectively. This step ensures you're not replacing parts unnecessarily while confirming the integrity of the system. In this sixth troubleshooting step, a thorough check for shorted wires in the FI main RLY outline is essential. Disconnect the specified parts, including the PGM FI main relay 2 and the PCM connector A, 50P, to conduct the continuity test accurately. The test checks for continuity between PCM connector A, number 8, and body ground, while ensuring that the relay circuit board remains removed. Confirming continuity would indicate a short in the wire. Thus, repairs will be required in the FI main RLY out wire. If continuity is not present, replace the relay circuit board and ensure to also replace the blown A7 fuse. This systematic approach reduces the chance of overlooking significant issues. Step 7 requires reconnecting the relay circuit board and measuring the voltage to identify any issues with the control circuit of the PGM FI main relay 1. After turning the vehicle to the lock mode, restore the circuit board and then disconnect the PCM connector A, 50P. Measure the voltage between indicated test points to determine if the battery voltage is present at test point 1. If battery voltage is measured, it indicates the circuit is functioning adequately and you should proceed to the next step. If there's no battery voltage, it's crucial to investigate further, as this suggests a failure in the circuit that needs addressing. In the 8th step, you need to check the +B IGP line by disconnecting the relay circuit board connector, C18P. After the disconnection, measure the voltage at specified test points to affirm whether battery voltage is present. It's crucial to do this while ensuring PCM connector A, 50P, remains disconnected. Identifying whether battery voltage is available helps confirm the condition of the +B IGP line. If battery voltage is absent, this indicates an open in the wire, necessitating repairs between the A7 fuse and the relay circuit board. Properly addressing this can prevent further complications within the electrical system of the vehicle. Step 9 focuses on open wire checks for the FI main RLY CL line. This involves connecting terminals A and B with a jumper wire, specifically targeting body ground within the off-lock mode. After making this connection, continuity between the specified test points must be checked to evaluate conditions accurately. Continuity indicates that the wiring is intact. Conversely, a lack of continuity necessitates further investigation. If continuity is confirmed, you must check for authorized service information related to DTCs that may appear, or substitute with a known good PCM. If successful, replace the original PCM to mitigate future faults. The 10th and final troubleshooting step entails conducting an open wire check for the FI main RLY outline. Start by disconnecting the relay circuit board connector C18P to prepare for inspection. Then, connect terminals A and B with a jumper wire for a reliable continuity test between specified test points while keeping the PCM connector A50P disconnected. If continuity is confirmed, it indicates that the circuit is functioning properly. If not, immediate repair is required in the FI main RLY out wire running between the PCM and the relay circuit board. This step finalizes the troubleshooting process, ensuring all connections are functional before putting the vehicle back into service. After repairs have been completed, a final verification is essential to ensure that DTC P0657 has been addressed correctly. Recheck for any DTCs to confirm the systems are functioning as designed without any lingering faults. It is crucial to verify that all electrical connections are secure and properly seated to avoid future issues. A comprehensive test drive is recommended to observe the vehicle's performance under normal operating conditions. Should DTC P0657 reappear during the verification process, revisiting previous steps is vital to ensure that the underlying issues have been duly addressed. Accurate verification helps ensure repairs are effective, providing safety and reliability. Preventative maintenance plays a critical role in avoiding recurring issues related to DTC P0657. Regular inspections of the wiring harness, connectors, and the relay circuit board can identify potential problems before they escalate. Testing the battery voltage at appropriate intervals ensures that power supply requirements are consistently met throughout the system. Regular examination of connectors for signs of corrosion or wear is also essential, since poor connections are a common root cause of electrical issues. Establishing a proactive maintenance schedule can significantly reduce the chances of encountering power supply circuit malfunctions. A well-maintained vehicle is less prone to complex electrical issues, offering a better driving experience and reliability. In conclusion, DTC P0657 indicates a malfunction in the power supply circuit of the PCM, a vital component of the engine management system. Utilizing diagnostic tools like the Honda Diagnostic System, HDS, effectively identifies, clears, and confirms DTCs for efficient troubleshooting. Each systematic step in troubleshooting is crucial to determine the root cause of the malfunction and to implement appropriate repairs. Regular preventative maintenance is essential for minimizing future occurrences of this code. Addressing this issue promptly ensures the vehicle returns to optimal performance levels. Always remember, understanding the entire electrical system is key to effective diagnostics and repair. Please like and subscribe to the channel. See you next time.